Hi, I'm James McGuire, editor of eWeek. Today's webcast is geared for PostgreSQL enthusiasts and professionals looking for advanced solutions in edge computing. We'll explore how pgEdge distributed PostgreSQL can elevate your Postgres database deployment to meet the challenges of today's globally dispersed, latency-sensitive applications. To discuss that, I'm joined by two people who know a lot about the topic. With me is Michael Josephson, solutions engineer at pgEdge. Michael, very good to have you with us.
Hey, pleasure to be here with you.
Also with me is Philip Merrick, co-founder and CEO of pgEdge. Philip, welcome aboard.
Great to be here. Thank you so much, James.
All right, so I want to let our audience know that we do have a question and answer box, so please feel free to ask your questions whenever you want to. You don't need to wait to the end. Philip, I think we're ready for the presentation whenever you want to get started.
Okay, tremendous. Great to have you all with us. Thank you for taking the time. So we are going to be talking about taking Postgres to the edge with pgEdge distributed Postgres. Why would you want to do that? Well, it's what you want to do if you have the need to service always on, always available applications that are accessed on a global basis. So that's what we're talking about. And my colleague MJ will be, once I've gotten through a little bit of talking and slides, will be actually demonstrating pgEdge with a live demo. So here's our agenda. First, we're going to talk a little bit about those demands on today's applications, then the use cases for a multi-master distributed Postgres database such as pgEdge. We'll delve into AI a little bit, and then we'll hit that demo and go to QA. So as I just said, today's applications, typically, if they're serious applications, have to be always on, always available, serve a global user base, and in serving that global user base, you might encounter data residency or data sovereignty requirements. These are some pretty tough demands. And whereas maybe even just 5 or certainly 10 years ago, users were much more tolerant of slow response times and downtime in applications. That patience is not there. And in any event, in many businesses, downtime and slow response times just are financially unacceptable. And so multi-master distributed Postgres is really an effective way of meeting demands, and that's what we're going to jump into here. So if you want to sort of look at the downside discussion of this, if you're not meeting these demands, it means significant pain in the form of poor customer experiences, lost revenue, poor customer satisfaction, because nobody wants to have to sit and wait for a page to load taking 5, 7, 8, 10 seconds. But that's what your users in Europe or Asia Pac are going to see. Maybe even your users on the opposite coast if you're here in the US. Many applications in the cloud are architected to run just in one single cloud region. So the question is, well, what happens when that cloud region goes down? Yes, the cloud provider will give you an SLA, but it's typically an SLA that gives you credits off of next month's bill, which probably doesn't help your business that much, and certainly doesn't help deal with your customers who are angry that you're down. You also have to, these days, consider that the old practice of having a maintenance window where you take your application down for some number of hours over the weekend or in an evening, that's not acceptable either, particularly if you're deploying it globally. So that's the kind of pain that our customers really seek for pgEdge to help them with in a globally distributed Postgres database deployment. We're not going to dwell too much on the product other than showing it to you, but just quickly, some of the features and the way it works is it's built on the idea of asynchronous logical replication. So if you're going to have geographically distributed database, the copies of the database, you're going to actually have them update asynchronously, because the speed of light is a thing, and your application can't wait around for write operations to take maybe as much as a second or more across the global network. And so it's quite common for this kind of distributed architecture, when it's geographically distributed, to work on an asynchronous basis. Because it's asynchronous, there is the possibility of write conflicts, and built into our product is a set of conflict resolution algorithms and some conflict-free data types to avoid conflicts in the first place. We've done a lot of work to enhance our system for fault tolerance and for high performance, and to support ultra-high availability. The interesting thing about a geographically distributed database system is that support for ultra-high availability at one very important level is built in inherently, because if one node goes down, then you have the other nodes available to service the transaction traffic. And that is something that our product actually manages automatically in the background by taking advantage of latency-based DNS routing, where the product will ensure that traffic automatically goes to the nearest node that is still available. And then we have something we call the anti-chaos engine that makes sure that these replicated databases are remaining in sync at all times. So just quickly, those are some of the high-level features of our product. Let's jump into the use cases for this kind of product. So we think there are 4 or 5 main ones. This desire for low latency, getting those page load times down on a global basis, ultra high availability, making sure that your distributed system is up at all times and hitting 4 nines of uptime or even 5 nines of uptime. You can use multi-master Postgres to achieve a geographic scale out if you're hitting the wall with your current Postgres system. And then obviously of interest these days are AI applications. Virtually every company is either working on AI applications or working to put AI into existing applications. And distributed Postgres, along with some Postgres extensions like pgVector, is a fantastic solution for pushing AI inference out toward the edge where the users are. And then finally, those who come from the Oracle world will know that Oracle does have a solution for doing geographically distributed database, and that is Oracle Golden Gate. But as organizations think about moving off of legacy databases like Oracle, they need to see a distributed capability. And if they go to Postgres, we can provide that distributed capability. So let's talk a little bit more about low latency. So the idea is we want to reduce round-trip response times for distant users, and we do that by putting the entire application stack, including the database, closer to users, and we replicate that entire application stack in some number of locations around the network. We've found, working with our customers, that even just 3 nodes or maybe 5 nodes can make a material difference. If you're serving both North American and European users, a node on the East Coast of the US, a node on the West Coast, and then one in Europe will do a great job of servicing users across North America and Europe. If you have users in Asia Pac, then maybe one in the US, one in Europe, and one in Asia. And the practical implication of this is, if you look at this diagram here, a fairly typical application, the application stack is hosted entirely in the US East Coast, most likely Northern Virginia. Happens to be where I'm located right now. And so even your West Coast users are going to see slower page loads, and certainly your European Asia users much slower page loads. So when we move to having 3 nodes in that configuration I described, one in Europe, in this case in Ireland, US East Coast, US West Coast, we've now got a much more consistent set of response times for our global users. Ultra high availability. I talked already about how this kind of replicated distributed database system has inherent disaster recovery and failover built in. In fact, it's not even failover because you just have the traffic failover to the surviving nodes. Within the pgEdge product, we support both cross-region and inter-region failover, failover between availability zones in a single cloud region. The upshot of these architectures, again, is if you're going to be doing this across some geographic distance, then you are going to want to do this asynchronously and not synchronously. Actually, within a region, it's perfectly fine because of the low latency. It's perfectly fine to have synchronous. Hello, my slides are moving on their own. Have synchronous updates, but for geographically separate regions, it definitely needs to be asynchronous. This architecture could also work multi-cloud and hybrid cloud. So you can support applications that are actually crossing over between multiple clouds or between on-prem and one or more clouds. Interestingly, in financial services, the regulators are starting to get worried about cloud concentration risk. And this is not just the idea that the organization needs to be working with multiple cloud providers. It's actually on a per application basis. Is an application going to go down because it's running entirely in one cloud? Is there ability to fail over to another cloud? And that's something that our distributed database architecture will support. Those of you who've been working with Postgres at scale know that there are some upper limits on Postgres scalability, particularly when it comes to compute. If you're in danger of hitting those limits, you can look at what is called geo-sharding or geographic sharding to break up the workload. So if your workload actually does have geographic locus to it, so you've got users in the Asia Pac region, that they're going to be having essentially their own sort of subset of the data that they're working with. Similarly, Europe, North America, that kind of workload can be very successfully scaled out using this geo-sharding approach. And that's going to give you higher throughput and better performance. And of course, you're going to get those high availability and latency benefits that we just talked about. Now for the exciting one, the truly exciting one, AI inference at the edge. Those of you who've been working with AI applications, LLMs in particular, know that the whole end-to-end processing actually can be pretty time-consuming, and you have a latency problem. Now, you don't want to compound that latency problem with geographic distance. And so increasingly, AI practitioners are realizing that for a lot of applications, again, you want to think about getting as much of the processing as close to the users as you can. We've got customers who are very successfully using pgEdge and the pgvector extension to allow this to happen. So pgvector, if you don't know, is a popular Postgres extension that makes it possible to store vector embeddings in the Postgres database. So you don't need to go to one of these specialized vector databases, and you can have your vector embeddings in the same database as your other data, and perhaps the data that leads to those embeddings. So that's actually a pretty exciting combination to put pgvector together with pgEdge and get AI processing, AI inference happening closer to where the users are. So we have a customer we're working with. They have a fantastic AI application that they've been very successful with, but they have customers, major customers in Japan, and those customers have been seeing something like 7 or 10 second response times on their queries, and that is not acceptable to them. And so with pgEdge, they can bring that down substantially. So you're going to use this in conjunction with an LLM that's going to allow you to create the embeddings in the first place. And actually, some of the LLMs you could actually run or access on a regional basis. SageMaker, AWS supports that, doing it regionally. You can access Azure OpenAI, not OpenAI directly, but Azure's OpenAI implementation is implemented on a regional basis, which is also important if you're having to deal with those data residency, data sovereignty requirements. So AI inference at the edge is a thing, and pgEdge can play a role in making that happen. A few other considerations. In technology, as with a lot of things in life, there is no free lunch. And so there are a few other things you have to consider here. We find that most Postgres applications run happily on a pgEdge distributed cluster, but there may be some modifications that you need to make. You need to make sure that your application is actually going to be compatible with the asynchronous logical replication model, which, without getting into too much terminology, means that we're working with the eventual consistency principle, and so your application needs to be able to deal with that. Most applications can. All your replicated tables have to have a primary key, although that's usually pretty fixable if it's not the case. Is the workload relatively conflict-free? If it's not, we can work with you to adjust the schema to make that more the case. And do you actually have transactions that need to be synchronous, where you need to make sure that that particular data is going to be updated consistently all at once around the network? So just a few considerations, but for the vast majority of applications, certainly not a major problem. We're obviously focused on the database, and getting the database distributed is the hardest part, and we take care of that for you. But you've also got to think about the other components of the application stack and how you manage your deployments. You want to be using an automated CI/CD deployment tool or set of tools, so that you can ensure that you are properly replicating the components of the application stack to each of the locations. As you think about your solution to going distributed in this way, is the solution fully open, or is it proprietary? Are the components available open source on GitHub? pgEdge distributed Postgres is available on GitHub. We make the source code available to our customers and actually anybody else who's interested. And then in the Postgres distributed world, pgEdge is 100% based on Postgres, but there are other solutions that are compatible. And they're fine databases that came up through the NoSQL world, but they are Postgres compatible and not fully Postgres. And so, is that going to cause you to have to deal with a lot of migration issues, code migration, code redevelopment? Is it going to be the case that moving to that product is actually going to put you outside of the Postgres ecosystem? Will you be able to use all of the Postgres tools and applications and actually even expertise and skill set of your developers in that particular database product? So just some of the considerations to think about as you look to going to this low latency, ultra high availability Postgres at the edge world. And with that, I've done more than enough talking for now. And so I'm going to turn things over to MJ, who is actually going to show you the product itself.
Perfect. Thanks, Philip. All right. So before I jump right in, let me provide a tiny little bit of context on the underlying architecture to set the stage. And then I'm going to show you two demos real quickly, and then we'll open it up for Q&A. So being multi-master really opens up a variety of different core capabilities for those that need it. The ability to write to multiple different data sources at the exact same time is tremendously valuable. It also opens up opportunities to be tolerant to certain disaster circumstances. It also allows you to load balance your data across multiple different nodes, which can be helpful, especially for some of our customers which have their write node can be overloaded just due to the amount of connections and data going through it. By having multiple write nodes, that really opens up a variety of different core capabilities and ability to resolve certain business requirements. In addition to being having the ability to have multiple write nodes at the node group level, we also do support physical replication at the node group. So you could effectively combine both the asynchronous replication with the physical replication, providing the highest levels of uptime. Just again, ensuring that the data is always available regardless of the different circumstances that may effectively arise through the nature of business. Cloud providers, regions go down, availabilities go down on occasion, and being able to seamlessly handle those circumstances is really critically important. And the great part about the way we've architected the platform is it really allows you to be flexible in the way in which you want to design the underlying infrastructure. With pgEdge, you can kind of mix and match some of these capabilities. You could have physical replications for a particularly critical area, or you could not, and you can kind of leverage the best of what you specifically need at any given time to make sure that you're always on. You're getting that optimal experiences for those end consumers of the data, and being able to update and adapt your application as needed. So there are two specific demos that I want to show. We're working on top of the Northwind dataset in both circumstances because it's a set that a lot of people are already familiar with. In this case, what I want to do is I actually want to start with showing our Northwind application. Now, the really great part about the Northwind application is this is available for all of you. So if you want to navigate to northwind.pgedge.com, you'll actually see this application, and it'll actually be responsive to your circumstances. So depending on where you're at throughout the world, it's going to route you to the closest pgEdge node to you. In this case, since I'm based out of that greater Los Angeles area, right in Rancho Cucamonga, you can see me right here. I'm being routed to the Portland data center that we have here, but you can also see how these are all current users throughout the world using this application, playing around with it, and you can see how they're being routed to that closest node. So you're getting that, and as you're going through and as you're using the specific application, you can actually see the responsiveness of the application as you're interacting with it, and you can see the time it's taking to run certain queries against it. So it's kind of a neat way to get a little bit of visibility into that low latency capabilities of pgEdge, and we've just made it all available to you all to have the opportunity to spend a little time playing around with it. So I highly recommend that. You'll actually notice here can also see the time it would take me for interaction with some of the other nodes within node groups within my cluster here. You can see here the one in Europe being a bit of a distance, so I wouldn't want to necessarily interact with that one right now. But this is I definitely recommend take a look at that, and it's a great way to see a little bit of pgEdge. Now, let's talk about a circumstance that comes up and is commonly asked for. Let's say I've got a set of users that are globally distributed. So this could be emblematic of really a variety of different regions. In this case, something that comes up commonly here is let's say US West, US East, and EU West. In this case, I want to ensure that I have my lowest latency for my end users. Should any specific interaction happen, I want it to be kind of optimal, getting that ideal customer experience. I want that redundancy of data. Now, one of the great things too with pgEdge is I can have both my global data replicated across all my specific nodes, and I can also have data specific to say like EU or US, right? So you have that ability to be to handle data residency requirements within pgEdge. And you also have the ability to handle fluidly circumstances that may happen, like let's say a region or availability zone goes down. You can have that redirection take place. As an example, with the Northwind app that you're just seeing, since we're using latency-based routing there, should that node go down, you would be redirected to that next closest. So for my circumstance, that would have been US East 1. In the EU West one, they would have no difference in routing, right? That's a great thing about that, the way in which we've configured that. So let me go ahead and show that. So I'm going to pull up another application real quickly here. So 1 second. All right. So let me log in real quickly. Now, as with this application, I'm also using the Northwind dataset. I'm actually multi-cloud in this circumstance, so I have a couple of nodes in AWS as well as one in Equinix, which is just where you have flexibility in pgEdge. You can be multi-cloud if you want. A lot of our customers want to be, say, in AWS or Azure, but you really do have a lot of flexibility with how you can effectively handle that. And this is just emblematic of one way you can handle the application layer. I've already shown you another. In this circumstance, I have the 3 nodes spread throughout the US. So I've just kind of got a US data set. I wanted to use Equinix in this circumstance because I wanted something that was accessible to the central US, as opposed to being mostly US West and US East. I have the ability to update information related to, say, my employees. Let's say I want to update their telephone number here. I can then see that that data is effectively propagated across all nodes within my cluster. Now, I can also update any of these nodes. So as an example here, let's say I want to update this node on the US East. It's also going to be updating it. That's a great part about multi-master. I can write to any of the specific nodes as I want, and I have flexibility on how I would design my application or the consumers of my data to maximize this specific capabilities. From here, what I'm going to do is I'm going to take down my West node here. I'm just going to stop that instance here. So I'm pulling up my EC2 instance. I'm stopping it, and let me go ahead and refresh my screen here. So let me do a quick refresh. And as you can see, that is now down. And I have been redirected to my Dallas node, since that's the next closest one to me. I still have the ability to make an update as I need to this particular this node as needed, and that will be effectively propagated across the other nodes. Now, should my should my EC2 instance come back up, another great part of the platform is it's able to basically resynchronize that data. I'll go ahead and start that right now, so you can actually go ahead and see that process here live. So I just went ahead and started that. It might take a second for that EC2 instance to start back up. So let me go ahead and refresh here. Looks like that is now up and running. And let me just pull up my employee information, and you can see that that's been updated. So again, it's just really to the power of pgEdge, where when certain challenging situations arise with businesses, as they will inevitably happen, you have new technology to effectively handle those particular circumstances. So I think this was a way in which we could kind of walk you through that specifically. So those were the two demos I wanted to kind of walk through. So I will go ahead and open it up for Q&A. There was one question that was raised already, so I wanted to just answer that on the fly. So pgEdge comes in a couple of, we have a variety of different ways in which you can leverage pgEdge. In this particular circumstance, I actually wanted to continue to share my screen here. So give me 1 second here. With our, let's see here, let me share. The question was, how do you handle connecting to pgEdge? So I'm pulling up our pgEdge Enterprise Cloud. What you'll see here is with how it's been set up and configured, it actually gives me that latency-based routing, which I have that end connection screen to. I can also connect individually to my specific nodes as I may need to effectively do so. So you have both the flexibility of, say, using latency-based routing, connecting directly to the specific node that you may have. You just have a lot of flexibility with relation to the way in which you can connect to your pgEdge servers. Now, again, with this, since we're a native Postgres extension, you don't have to install any sort of custom pgEdge specific Postgres connection software. You can leverage your current integration to Postgres with pgEdge, because we're effectively that extension layer right on top of Postgres. So anyways, wanted to just answer that one before we kind of open up for additional questions there.
All right, thank you, MJ. So just in summary, what we've shown you is that a multi-master distributed Postgres database, such as pgEdge, is a strong solution for low latency for your global user base, making sure that everybody sees a consistent user experience with uniformly low page load times. MJ showed how inherently a multi-master distributed Postgres system provides ultra-high availability, including for zero downtime maintenance as well. I talked a little bit about AI inference at the edge, working with LLMs and vector embeddings, and making AI applications more performant for a global user base. And then I also talked briefly about using pgEdge distributed Postgres to break up your workloads on a geographic basis so that you can overcome some of the inherent upper limitations on Postgres performance. So I think you'll agree that in these ways we really are taking Postgres to the edge, both literally and figuratively, and really appreciate the time and attention. And I think without further ado, James, we could open up for Q&A.
Here's a good one. I'm interested in trying out pgEdge. Is a trial version available to use?
Yes, absolutely. So we have something we call the Developer Edition, pgEdge Cloud Developer Edition. And the whole goal of this is making it easy for people to get started with pgEdge. This includes a free tier up to 12 gigabytes across your distributed databases. And it's as simple as going to pgEdge.com/get-started, as you can see in the URL here. And I think I've already segued to what we were supposed to close with, which is the giveaway. As you can see, we do have, for the first folks to sign up from this webinar today, an offer of a free t-shirt, albeit in the US only.
It's a pretty cool t-shirt. We've got some more questions. Is there a way to prevent certain tables from being part of replication?
Yeah, you have a lot of flexibility with how you want to set up and configure pgEdge. You have the ability to have all tables as a part of replication. You can have a subset of it. You can have certain tables on certain nodes be a part of replication. All of that is flexibly available with pgEdge.
All right, here's one. What versions of PostgreSQL are supported with pgEdge?
I think we support. Oh, go ahead, Philip.
Sorry. Yeah. So we currently support 14, 15, and 16, and we are eagerly tracking the progress with Postgres 17. It's our policy to support new Postgres versions within the first month or so of them becoming available.
Mm-hmm. Okay. How can we monitor replication and other metrics?
Great question. So one of the great parts about the Spock extension is it has a variety of pre-built capabilities, including information like replication lag, also conflict resolution, so understanding what decisions were made and why they were made. You'll actually see a Spock schema installed with pgEdge that will basically give you a variety of different core pieces of information. And in fact, we also do make even broader set of information available if you wanted to use an external data visualization tool to take a look at that as well. So there's a variety of different capabilities we have, really looking to best fit into your own specific business requirements.
Okay. Can you share more about how conflicts are handled?
Absolutely. So we have a variety of different ways in which we can handle that. There's basically a configurable conflict resolution setting. Based on that, you may choose like last update wins, first update wins. Maybe you have a specific node that you always want to take that node's value. You have that ability to basically determine it. And then you also tracking specifically when there are conflicts that arise. We have some customers that are also doing tracking against that. So if you see kind of an increase on conflicts that are happening, you can be notified so that you can kind of investigate it. And also, should there be some circumstances where you have data get out of sync for whatever specific reason, we also have that ACE engine, which will effectively ensure that all of your data is properly synchronized across your entire cluster. So we have a variety of different ways in which we're handling specifically in pgEdge.
Great. Well, that's the end of the questions. MJ, Philip, a lot of good material. I certainly learned a lot. Thank you so much for sharing your expertise today.
Absolutely, our pleasure. And again, there is the detail on how to get started with pgEdge Cloud. And that cool T-shirt that we have on offer for signups.
There was a quick question that came in here, and I don't know that I was trying to share this a little bit earlier, and I think my screen maybe had been switched back to our sharing a presentation view. Yes, there is absolutely a you have a couple of ways in which you can set up the visualization of your current cluster. pgEdge has our enterprise cloud here, which effectively will give you visibility into, say, your cluster, right? So as an example here, I have a cluster that's in Azure across the US. I can get some information, including like what my database is, some of the core metrics that are with relation to the performance of that specific cluster. I can then drill into my database here. So we have all of that flexibility built in here. But again, some people want to see this in, say, AWS or Azure. You can use CloudWatch, that type of thing. So again, we have a lot of flexibility there. But I did want to mention that this is available for you all. So appreciate you raising that question.
And MJ, that's the question about the connection string in a language like Java. I want to make sure we did answer that.
That's yes, I answered. That was the first question I answered.
I thought so. Just want to make sure. Okay.
Yeah.
I think we're good to go then. If unless the two of you wanted to say anything else, I think we're in good shape.
No, we just appreciate everyone taking the time and the attention. Thank you.
Thanks all.
Thank you. Bye-bye.